This is the second part of the video where we were discussing about how to train any large language model with reinforcement learning with human feedback. In the first section, we discussed about various steps of reinforcement learning with human feedback and theory behind it. If you haven't seen my previous video, please go and watch that and come back so you will have much more knowledge while starting out. In this video, we will complete our steps to train the reward model and policy model with PPO. After the first step, that is training a policy model, we were able to generate a summarized result. If given text and how we will be able to use that result to create a new dataset with the help of human, or how we can use ChatGPT to remove human in these steps. The dataset created from the first step will be used to train our reward model, that is for second step. So after the first step, we'll have the dataset as this, where human will judge the output of the policy model that we train in our first steps to be good or bad. In this case, chosen or rejected. Now let's look at the code for the steps 2 and step 3. As said, we are using TRL library as of now. So let's import the required libraries as we move forward. We require a torch, transformer, and as we are using TRL libraries, we need to import the reward trainer from it, and dataset to load our model from the Hugging Face, and pandas and trainer argument from transformer. Now, as this is to train our reward model, we will require a reward trainer from the TRL libraries. We'll discuss about it as we are going through the code. So if you haven't installed the particular libraries as torch, transformer, TRL and pandas, you can simply do pip install from here, like pip install torch, transformers, TRL and pandas. By this you will be able to install all the required packages. Now let's define a model, tokenizer and data path, which will be constant through our all the training process of the reward model. So model path is of Hugging Face repo. We were using TinyStarCoder from the beginning, so we'll be sticking with it as of now. After the step 1, the dataset looks something like this, where human will judge the output of the policy model that we train in the first step to be the good or bad. In this case, is chosen and rejected. The chosen is the summarized result that is used by the human to be the good, and rejected is the sample for the same summarized result that the model generate, which is considered as a bad. We'll feed these models outputs to our reward model to make our reward model be more concise in choosing a right output for the text provided. So let's do that. Now the step is to read the data file. You can download the file from here as Parquet, train test valid and valid 2. As of now, you can use test or valid the faster training. In this case, I have already downloaded the files and it's in the directory for test as Parquet, where I read it with pandas and loaded the same data frame in the Hugging Face by dataset from pandas. Now after this, we will define our model and the tokenizer. Since to define a tokenizer, we can just write autotokenizer.from pretend and model path, which is StarCoder as of now from big code. And to load the model, we can simply write auto model for casual lm dot from pretend with passing an model path. The auto casual lms and transformer are from the Hugging Face that we have just imported above. After this, defining the model and tokenizer, we can just create a data loader from the dataset we just have earlier. Now to do that, what we really want to do is tokenize the dataset. Now to tokenize the prompt, now in this case we have two fields as prompt plus chosen response and prompt plus rejected response, which is the two fields that we have seen earlier as chosen and rejected column in our data frame. We'll simply concatenate the prompt with the chosen and prompt with a rejected to create a sample as this. Then we pass the chosen response to a tokenizer along with rejected response to a tokenizer and get an input IDs along with the attention marks for each column that we have in the data frame. After that, we will simply map the function to a data frame. Now in this example, we can simply map the function by raw dataset.map. In this case, it will return the input IDs for the chosen and input IDs for the rejected along with its corresponding attention marks. Then we will split the dataset into 10 test splits. By default, it's 0.2 for the test split in the Hugging Face. Now the next step is to create an argument for our training pipeline. In this case, we require output directory to save our model, and number of the training step we are just using as 1 for now. If you have the GPU, you can just turn the no CUDA to false. Else, if you want to run your training pipeline in GPU, you can just comment this out. And we just pass our learning rate as 1e to the power minus 5. After defining a training argument, we can just pass our dataset to a reward model for the training. Now to do that, we'll just initialize the reward trainer as reward trainer by passing the model tokenizer and train and test split from our dataset. And to train our model, we just simply can call the trainer class by train.train. So in the background, what actually happens is this. We pass the chosen into a model defined as R and rejected to a model as R and calculate a loss according to it. In this case, the model is tiny stack order. You can use any model as you like in this reward model, and we calculate a loss as this, where the text 1 is chosen and text 2 is rejected. In this way, the reward model will be trained to identify if the output generated by our policy model is good or bad, and it will give a score according to the output that the policy model generates. Inside this as a code, you can see in the TRL library as TRL, and in trainer you can see a reward trainer. Here it is doing the same thing. You can see the reward chosen is passed to a model where the model is stack order in our case, and rejected sample is also passed to a model as an input with its input IDs rejected and attention marks rejected that we have created in our data loader just before this for creating a function. Then we create a loss and we do backpropagation according to it to train our model. After this, the model will start training. So that's all for training your one reward model. Now, after training the reward model, just save the model if you think loss and other metrics is significant good for your use case by trainer.save model in the directory you want to save. Now, finally, we will see the last step of reinforcement learning with human feedback, that is training our policy model with PPO. In this step, we require all the models that we have trained in step 1 and step 2. So let's get started. The import is similar to that of the reward model, but we here require a PPO trainer, PPO config, and auto model for casual LM with value add from TRL library that we have installed earlier. We will see how to use this in the later part of the video while going through the code. So the first step is always defining the constant that will be same throughout the training process, that is model path and data path. The data we will be using is same as the data we use in reward model training, that is chosen and rejected data sample from the Hugging Face. Now let's define our model and tokenizer. As said, PPO model we require the model from the step 1 and step 2. So step 1 model is stack order model, which path is the model path. And for the reference model, we have just save our reward model in the directory as this. We'll just load the model from this directory from auto model for casual LM with value add dot from pretend, and we can just use tokenizer as it is. Then instead of creating a data loader function, let's just map the dataset in the lambda function where we tokenize the chosen column from the dataset that we have just got earlier and store only the input IDs in the data sample. After mapping the input IDs, we'll have the new field columns as input IDs in the data frame or dataset that we have just created earlier. Now let's initialize a PPO trainer where we require the config file, the stack order model which is an policy model that we have trained earlier, and stack order ref is an reference model that is reward model that we have trained in step 2. The config file that the PPO config use is this, where we set the learning rate and steps to train our model along with the model path. So you can stop here and train the model as this, but to generate a better result, we will play with the reward generated by our model to make it more robust to the change in the dataset by introducing a penalty for every bad result the policy model generates. To do this, we will define two control string as negative and positive. In our case, the negative is a rejected samples and positive is a chosen sample. Now to define a penalty function, if the output is negative, we'll just introduce a negative to a score the reward model generates, and if it's positive, we'll give it as it is. In this way, if the reward model finds the output of the policy model to be the negative, we'll introduce a penalty to the model that will lower the reward that the model has gained in earlier. Now before moving to the final result, let's create a getScore function which produces the score for the result that is generated by our policy model. This is actually a reward function for the reward model. Now comes the training loop. We'll train the model for the epoch 1 and pass the batch of the data to the model by PPO trainer dot data loader as this. Now for all the chosen column, we generate a response as PPO trainer dot generate. The response is the result, that is the summarized result for a text that the policy model will generate. After that, we'll just get the score from the reward model and get the penalty for the result by passing the logits to a POS logits to reward that we have defined earlier in our case. Then we simply operate the loss by the PPO trainer by just saying that PPO trainer the step by passing the query tensor, response tensor and the reward. After this, the model will start training. So this is how you train the large language model through reinforcement learning with human feedback. Hope you learned something new. And if you have any query, feel free to message me or comment. I will love to help. Thanks for watching.